Um, Thank you all for actually joining me in this talk. I'm very happy to share our experiences we've had in the last few months. It has been an amazing journey we've been on in the last few, let's say, 18 months since we had the big ChatGPT explosion, I'd like to call it. And we've been building a few AI factories in our day. We can just continue like this. Who's Amber actually? Amber is in one form one of the oldest NVIDIA partners out in the market. It has been founded in 2006 by one of my co-founders, Thomas Inninger, who has always been a professor at the Technical University of Munich. Back then it was called Fluidyna, and Thomas has been one of the first people actually working with CUDA and actually developing on GPUs. Back then a simulation software. And that has been so successful that he actually started also selling NVIDIA hardware. Back then, NVIDIA was not the powerhouse it is today. So he started very early in working with NVIDIA on AI infrastructures and GPUs. In 2016, Fluidyna back then has been bought by a company called Altair. Altair is a US simulation company who were very interested in this GPU code, and with that, we actually got into the big market of AI globally. And 2 years ago, Altair actually decided, oh, NVIDIA is now getting more of a danger to us because of Omniverse, because of a lot of development going on with NVIDIA, and they asked us to maybe switch and do something else internally, but I and the team at Altair, we decided that, no, we think AI is going to be pretty big. AI is going to be pretty important. So in 2022, we decided to found Amber and be a standalone company. And since then, I think we have been one of the strongest and biggest partners in building AI infrastructures for customers, and these customers involve really everything from big enterprise customers to startups to governments, facilities, etc. globally, mainly in EMEA, but we see developments going all around the world. So that's us. And then what are we actually talking about? A little bit of an intro where we are at and why AI factories are getting more and more important. And I'll just jump into 2006, basically, when NVIDIA released CUDA. And started this entire wave with GPU coding. And then, of course, 2012, AlexNet, we like to call it the first contact with AI. And since then, it has been a rapid development and growth. We see doubling of sizes of models. We see doubling of systems, of performance constantly. And NVIDIA actually saw that the OEMs back then, they weren't really ready for AI, and they didn't believe in it that much. So in 2016, NVIDIA decided to create their own system. Now, back then, it was basically the first AI factory in a small form factor called the DGX1, created by NVIDIA purposefully for AI, nothing else. There were no holds barred. It was the fastest thing you could do. And they continue to develop this solution, and we'll see more about it in a second. But what also pushed this entire wave is in 2017 when Transformers hit. And since Transformers hit the market, we've just seen a crazy development. Basically, models have been popping up to do all kinds of things. And this resulted in 2022, the big ChatGPT open AI explosion. Since then, it is on everyone's mind. Everyone is working with AI. It is in the mainstream media. Everybody at least has heard about it. And it's on every agenda, in every enterprise. And there has been rapid developments in all kinds of areas, which also resulted in Gen AI. And Gen AI, of course, is a big factor in every AI strategy nowadays, and it's pushing businesses all around the world in creating value. And that also started a whole bunch of startups with amazing, innovative ideas, getting funds as well, who need a lot of resources. And all of this results in what Jensen calls a new industrial revolution. It is a very big thing to say, a new revolution. The last revolution propelled humanity into the era we are in today, and Jensen believes that we will face another leap like this with AI. And of course, this results in a giant market. 100 trillion is what NVIDIA is saying. And to cover all of this, we need AI factories. We need to gather data. We need AI factories to work with this data to then basically create intelligence. And if we take a look at the state of AI, generative AI adoption globally, we actually see, and this is one of the favorite things Jensen says, spend more to save more. We see that the more you spend in AI, and Gen AI especially, the more you get back. Most companies report 3.5 of a return of interest. Select few actually really know what they're doing, and 5% of them actually get up to 8 times of their investment back. Estimates go as far as saying that 33% of all G2000 companies will in some way exploit business models to double their monetization potential with Gen AI or of Gen AI. And of course, we see a lot of development in software development via Gen AI, and which results in a lot of software tests being written by Gen AI and increasing the software code and usability of software. So we know why Gen AI is important. And now we take a look at what AI factories looked like back then and what they look like today. On the left-hand side, we see 2012, the Titan supercluster, 20 petaflops. It was an amazing number back in the day. And also it took an amazing amount of power, 8,200 kilowatts of power to run this beast, almost 20,000 NVIDIA GPUs. And this system, if we calculate it in money today, considering inflation, would be worth 130 million US dollars. That's a lot of money, right? But let's take a look at what we get nowadays to cover the same amount of performance. 2023, the DGX H100 based on the Hopper GPU, the current gen of NVIDIA, even more performance, 32 petaflops. Only takes 10 kilowatts of power. That's quite a lot less power, right? That's a huge jump down. It's only 8 GPUs, way less GPUs, costs you less than $500,000. And that's in 11 years. That's quite a jump. And that actually takes me to a very, very important point about AI factories and the state of AI computing in general. Because you see it on the news all the time. AI is heating up our planet. AI is taking so much power. It's in everybody's talking about it. Data centers, they need more power than almost anything else. That's true. AI needs a lot of power. But if we actually take a look at what AI can do and what GPU systems especially can do, right? If we convert old legacy tech, CPU servers, not every workload can be transferred to GPUs, but those that can be, if we would do that, we would actually save a huge amount of power. So accelerated computing is not eating power, it is saving power. We just need to use it on a large scale, and we need to transform old data centers to actually move away from CPU servers to GPU servers. It's also, of course, saving a lot of money, right? 960 CPU servers are expensive. That's 10 million. You can cover the same for 800K with just 2 GPU servers. And in my opinion, way more important with 5% of the power requirement, right? That's a huge saving. And I believe, honestly, AI is a key way in solving huge amounts of problems that humanity is facing. It will not solve it by itself, but it will give us the tools to solve them. And we should not break this amazing progress we have right now because we take a look at the power it requires. Yes, it is a lot of power, but it is less power than the old tech. And not only is it less power than if you move from CPUs to GPUs, if you actually move with the new generations NVIDIA is releasing every year or every 2 years, even then you're saving a lot of power. If you just take a look at this, if you take a GPT 1.8 trillion parameter model and want to train it in 90 days, if you want to do it with Hopper, you will need 8,000 GPUs, 1,000 systems. That's what we're doing right now. It will take you 50 megawatts of power. That's a lot. If we want to reduce this, next year's generation of Blackwell, the GB200, with actually 72 GPUs per system, which will be liquid cooled, but more on this in a second, it will take a quarter of the power, a quarter of the GPUs. So it is extremely important to actually use the new tech that is being developed. Yes, it is a challenge in keeping up with all of this, but please reach out to us. There are life cycle ways to actually move from the old generations to the new generations, and to make sure you always keep this in mind. And don't forget, power is not for free. Power is expensive, especially in Germany, right? Power is really expensive here, so this can actually be a massive factor in your business as well. So yeah, that's where we are. 2022, ChatGPT explosion. A lot of stuff started happening back then. Then we had experimentation. We see new innovative stuff happening daily. We see new models almost daily. Just I think it was yesterday, right, when ChatGPT or OpenAI released their new model, and there's so much happening. It's almost hard to keep up with everything. But what's key is we're still at the beginning of all of this. There's a lot of experimentation going on, and that's important, but what we're facing in the next years will actually be production. We'll move away from just training, we will move into inference. We will move into using these systems that are being, or these models that are being trained. And some conservative opinions think that this will mean an increasing need for computational resources by at least 8 times. Others say by 20 times. We're moving so fast, it's hard for anyone to keep up. And not only is inference going to be a huge thing, but I mentioned before, transformers were actually a key aspect in the development of AI. And if we take a look at before transformers were a thing, we saw an increase of computational resources needed by 8 times every 2 years. That was huge. That was a lot. But since then, it's 256 times every 2 years. That means you need to increase, you need to keep up. That means bigger and bigger clusters, bigger and bigger AI factories. One system is not enough anymore. You need to increase the clusters, you need to realize how to build them and how to operate them as well. So that's the Triforce of AI, as I like to call it, for AI factories at least. AI factories, they are basically, let's say, 3 key components are making them. There's the GPU nodes, or acceleration nodes, however you want to call them, if it's not GPUs. And there's the AI storage. A lot of our customers think they can just keep on using their legacy storage that they have been using for ages. Doesn't work, and I'll explain why in a second. And then there's the internal networking. You need to connect the systems between each other. And you can, of course, also use Ethernet, and Ethernet is making huge jumps, and it's getting better and better. But we always say, if you want to keep up with the big players, and that's NVIDIA, then use their reference architecture, and that's InfiniBand. That is why they got Mellanox a few years ago. They are developing it rapidly, as well as their own GPU nodes. Why are these 2 things on the bottom and GPU nodes on top? What NVIDIA is always saying, building a huge cluster is like building best and fastest race car. But if you then skimp out on AI storage, on the networking, it's like putting tiny toy wheels on your cluster or on your race car, and then expecting it to win a race. Doesn't work. You need to keep in mind these 3 aspects, all of them. And most customers, they forget the bottom 2. They think about these fairly late and don't expect that there is a pretty hefty amount of budget that you need as well to cover networking and AI storage. Of course, connecting all of these is software and service. There's a lot of things you can do on the software side nowadays. It's very, very custom, very individual, depends on the project, the use case, what you want to do. And of course, there's the service. And NVIDIA is also covering a lot in that area. What we're seeing more and more is that enterprise-grade service is more important than ever for companies to move, if they want to move into production, right? They need to make sure that their cluster and their entire inference infrastructure is being serviced in a way that covers their business and does not hinder their progress and their development, their training, and their production, of course. And then all of this is built on the data center infrastructure itself. And as with many other infrastructures, we're facing now a time where the old infrastructure is not enough anymore. We're seeing that these systems require more and more power. They require or generate more and more heat. And all of a sudden, a air-cooled old old data center will probably not cover the next generation of GPUs we're facing. You have to imagine these GPUs, they suddenly have requirements of power of 1,000 watt and more, 1,200. This is an amount of heat that will get tough to handle physically with air. So we have to move into liquid cooling, and that is something you need to cover in your data center infrastructure. Not only that, weight. These systems, they're really, really heavy. If you see the new B200 systems from NVIDIA with 72 GPUs per rack, that's 3 tons of weight on 1 square meter. Most data centers will not cover this. They will. If you ask them to put your data your rack in there, it will just break through the floor. That will not be very conclusive to your training and inference. So you need to figure this out early, right? You're not going to build a data center from today until tomorrow. This is something you need to plan early to cover this, basically. And this is basically if you say I don't want to get into it. I just want to buy something. And this is the DGX SuperPod, the AI factory turnkey solution of NVIDIA. It has everything you need. It has the compute nodes now with the old DGX H100 upper generation, with all of the networking included, with AI storage included, with the software base command of NVIDIA included, with basically the racks, everything is in there. If you say, I have money and I want to start, this is the fastest way to start. And it is simple. It is something that NVIDIA has built themselves over and over. Their Selene cluster, their EOS cluster, everything is built on this reference architecture. It's not to say that you have to go with DGX. It is simply the easiest and simplest way. Our friends of Supermicro are here with us, for example. We can build a custom solution with their servers as well. And oftentimes it is the more cost-effective solution, let's say, but it takes more effort and it takes more experience on the side of the customer, even though we will help a lot and we will cover a lot. But generally, you want to start quick, you want to scale. That's also very important. You can scale this easily. You can go with the SuperPod. It's basically it's like ordering one product from us, then you will get this. And even if you have this SuperPod or an AI factory custom build, you will need to ask yourself, is your AI stack actually optimized? You will need to ask yourself if you can keep up with the monthly framework churn. You will need to ask yourself if you have the people who can operate this cluster. You will need to check if you're using all of the best performance libraries, if everything is up to date and running. And what's also very important is you will need to check what you want to do yourself, what you want to build yourself, or what you actually can buy as a service. I don't have the time, unfortunately, to cover everything that's possible or everything that NVIDIA is doing nowadays, but generally, they have a lot of frameworks. They have NIMs, we've already heard about them today. There is a lot of pre-trained and pre-built software, a lot of pre-trained and pre-built services that you can use, which you don't have to use yourself. So you have to think about your use case, you have to think about your regulations, your requirements, and then decide what makes sense. You don't want to waste time. The business and the market is moving so fast. 6 months lost means 6 months gained by the others. Now let's take a look at the cluster software, and I try to keep this short and simple because it's a huge thing and very individual, and you can go into very different directions. But I'm trying to cover the main things as I see them. And on top you see a few of the buzzwords around it that we see a lot. It's NVIDIA AI for Enterprise, which is basically their entire suite of software solutions and service, which covers, I would say, everything you need. And then the key factor around this is base command. This is their cluster management tool, which we will take a look at in a second. And I really like to work with Run AI, which now has been acquired by NVIDIA, but it is a great workload management tool. But the key things is basically infrastructure provisioning, workload management, and resource monitoring. And as I said, I have only 5 minutes remaining, so I'll be quick about this. Why is it so important? Because basically you want to make sure that all of the images on the different servers are being managed, that the cluster can be configured remotely, that you can share a common software stack, that you can, of course, also post-installation actually make sure that you can configure all of these different systems, make sure the networking can be configured, user authentication, GPU settings, BMC power settings, etc. There are a lot of things that the admins need to take into account. And you also want to make sure that the utilization of the system is overall good, and that you want to make sure that the health of the system is overall good. So that's why base command, for example, gives you the option to monitor the health of the entire cluster. Cloud integration is something we see more and more, and it's more and more important. We see a lot of customers who have the idea or follow something which I call own the base and spike into the cloud, or it's not just me calling it this, but a lot of people. And basically the idea is to own your on-prem cluster yourself. And if you, for example, for 2-3 months or a few weeks see that you need more resources to be able to spike into the cloud and to use the resources there, which of course makes it has to auto start and stop. When you stop, you don't want to run these nodes forever in the cloud and forget them, which is going to be very expensive, etc. Next. Then, of course, Kubernetes integration is really important. Base command, for example, also supports multiple operators like RunAI, Jupyter, Prometheus, etc. Jupyter integration is really important. Key factor of all of this is you want to make the life of your data scientists as easy as possible. Data scientists are very expensive, their time is valuable, and you don't want to annoy them any more than you have to. So basically everything that makes their life easier makes it easier for them to create value for your company. And then, of course, really important health monitoring and remediation. Basically, the idea here is that with the right software tools, you can make sure that any problems that may occur are being recognized early. So you don't want to have your cluster break down. You want to face these problems early on before you have any problems in production, especially, or for example, also in training, right? You don't want your training to stop and then suddenly lose weeks of time and power and energy because you don't have a checkpoint or whatever. So it's very important to monitor the health of your cluster as well, which base command, for example, does. And the NVIDIA service then helps you actually to cover all of these different things, right? It's very, very complicated to run a cluster efficiently. You need to think about all of these things all the time. Then if we take a step deeper into health monitoring as well, it gets very important. These GPUs are also very expensive. So you want to make sure that the temperature of the GPUs is being well kept. You want to make sure that the fan speeds, or for example, the utilization of the GPUs is running as you want it, and the memory, etc., that everything is running well. And what we're seeing more and more of is actually reporting and chargeback. So you, as an organization, want to make sure that you see who's actually using all of your valuable resources and what is he using them for. Is it just running randomly? Is he using it for important jobs? What does it cost me to basically support these data scientist teams? And so you want a software tool kit that basically helps you with the reporting and chargeback. As I said earlier, storage really important for AI factories. You can't just use legacy storage. We're very storage agnostic. There are a lot of different players out there. This is, for example, a system by IBM, which we love to work with. There's also DDN, NetApp, VAST, Vico. There are a lot of different players, and it takes time and effort to figure out the perfect system for you and your use case. I'd like to share these slides afterwards, but it's basically very important that you have a high-performance storage system to make sure that you're getting the most out of your cluster. Quick trends we're facing in the last few months. We are seeing specialized AI networks, and we're seeing very, very large models. That's basically the two developments we're seeing. What we are expecting, or NVIDIA is also expecting, though, is that these large models will take care of more and more of the specialized things that are happening. And what this also means, though, is that these large models will have bigger and bigger parameters, longer and longer context, which means more memory is needed, which means the inference system needs to be bigger on the other side as well. So NVIDIA is expecting that in the future, you will actually need these huge cluster systems to run the inference as well. Right now, there is still a bit of a divide between training GPUs and inference GPUs, but it's moving more into one unified. And as I mentioned before, data center requirements in the future, direct liquid cooling is the way to go. There is no way around this in the future. We need to get ready for it. And then I had oh, can I jump back? I had like a 4-minute video here, and I knew I wouldn't have the time to play it. So if you actually want to see the AI factory of the future, Amber and its partner Itera and their partner Sustainable Metal Cloud are working on an immersive cooled solution, which is really impressive and reduces the amount of power required again by roughly 50%. Why? Because you don't need to have fans running. You have all of these systems. You see it on the right-hand side. They're actually immersed in mineral oil, and they are therefore you can move the heat better, and you need less power to cool them. And the one picture on the left-hand side shouldn't be there, but basically it looks like a shipping container with all of these systems being immersed in the mineral oil. And we're getting the first containers in Germany in the next few months, by September, October, hopefully. And this will be a managed cloud platform which you can use, which will be sovereign here in Europe, which is very important. It will be sustainable, and it will hopefully free a lot of companies from the shackles of the hyperscalers and actually help us build compute resources here in Germany, in Europe, where we desperately need them. A last word from my side. There's a lot of work to be done. We see globally, Europe has amazing talent, and this talent needs resources, it needs GPUs, and we're by a factor of 10 behind the US, behind Asia, etc. There's a lot of work we need to focus on to enable this talent and to keep the talent here. And this is one way to do it. Thank you for your time.